Black holes are normally named because they usually don't reflect or emit light. They are only visible when they are feeding on stars or gas clouds that roam too close to their boundary, called the event horizon. Beyond the event horizon lies a tiny point called a singularity, where gravity is so intense that it infinitely curves space time itself. This is where the known laws of physics break down, meaning all theories about what lies beyond are just hypotheses. Black holes seem exotic to most of us, but they are commonplace to scientists. Physicists had toyed with theories about similar objects for decades before Albert Einstein's general relativity predicted their existence. However, the concept wasn't really taken seriously until the 1960s, when extremely compact stars were discovered. Today, black holes are considered an ordinary part of stellar evolution, and astronomers suspect our Milky Way galaxy holds billions of them alone. Black holes come in different varieties and can be modeled with different levels of complexity, like whether they spin or have an electric charge. So, if you jumped into one, your exact fate might depend on which sort of black hole you choose. At the simplest level, there are three kinds of black holes: stellar mass black holes, supermassive black holes, and intermediate mass black holes. Stellar mass black holes form when very large stars finish burning their fuel and collapse into themselves. Supermassive black holes live in the centers of most galaxies and likely grow to tens of billions of times more massive than our Sun by consuming stars and merging with other black holes. Intermediate mass black holes are still mysterious, and only a few suspected examples have been discovered, but astronomers think they may form through a similar process like others, just on a smaller scale. If you were free floating in space near a stellar mass black hole that wasn't feeding on anything, your only hint that it exists might be the gravitational magnification or lensing effect it could have on background stars. But as you flew closer to this strange spot, you will be stretched in some directions and squeezed in others, a process that scientists call spaghettification. If you jumped into the black hole feet first, the gravitational force on your toes would be much stronger than that pulling on your head. Each bit of your body would also be elongated in a slightly different direction. You would be literally end up looking like a piece of spaghetti. And this scenario isn't entirely based on theory and hypothesis. Astronomers witnessed such a tidal disruption event back in 2014 when several space telescopes caught a star wander too close to a black hole. The star was stretched out and shredded, causing some of the material to fall beyond the event horizon, while the rest was flung back into the space. In contrast to falling into a stellar mass black hole, your experience plunging into a supermassive or intermediate mass black hole will be slightly less nightmarish. Though the end result, a horrible death, will still be your fate, you might actually make it all the way to the event horizon and manage to start falling inside the singularity while still alive. In this case, at least in theory, you could see out into surrounding space, but no one would be able to see you once you passed beyond the event horizon. Even if you were holding a flashlight and tried to shine it out, the light would fall back down into the singularity with you. Meanwhile, you would see that everything within the event horizon was wrapped by extreme gravitational forces. This effect is called as gravitational lensing. No matter what type of black hole you fall into, you are ultimately going to get torn apart by the extreme gravity. No material, especially fleshy human bodies, could survive intact. So once you pass beyond the edge of the event horizon, you are done. There is no getting out. Even if you are still alive, you would have to travel faster than the speed of light in order to escape. But as we know, nothing in the known universe can do that. The closest known black hole to Earth is still a daunting 1000 light years away. However, astronomers suspect there are many more lurking much closer, perhaps as little as a few dozen years away from Earth. In fact, some researchers think that the distant solar system's hypothetical planet 9 is actually a primordial black hole that's roughly the size of a baseball. With that in mind, it's possible that if humans survive long enough to pioneer advanced space travel technology, we might be able to visit a black hole up close. And if we do, maybe we will even toss a few probes into the black hole to test what happens at the event horizon. Unfortunately, because nothing can escape the event horizon, not even information, we will never be able to know for certain what goes on when matter reaches the point of no return.